Hello students, let's start our second chapter, Magnetic Effects of Electric Current, part 1. So in this part, let's start about magnetic effect of current. In the previous chapter on electricity, we have studied that an electric current can produce heating effect. In this chapter, we will now study that an electric current can also produce magnetic effect. Along with heating effect, it can produce magnetic effect. How come? Let's see. Magnetic effect means magnet. What word comes in our mind? Magnet. What is magnet? Magnet we have studied in class 9th about magnet. Let's revise this. What is magnet? An object which is capable of producing magnetic field around it. An attraction force means where other pole will attract to a different pole. Like here you can see on the screen there is a bar magnet. The two poles, north pole and south pole. So not a magnet can exist with a single pole. Means whenever you will suppose you cut this magnet in 2-3 parts, so automatically it will generate its pole both the end. Okay, so magnet they are natural magnets. They are called lodestone, an ore of iron oxide, Fe3O4. You all know that a piece of lodestone found in nature are called natural magnets. Why we don't use natural magnets? So reason, limitation of natural magnets are they are irregular and odd shaped, and they are not magnetically very strong. So we don't use natural magnets, we use artificial magnets. This bar magnet is also an artificial magnet. Artificial magnet, why? Because it can be given desired shape and made very strong. We can produce we can increase the current in it, and it will be very strong as we want. Basic property. What is the basic property of magnet? When a magnet is dipped in iron fillings, we can observe that. Let's show you. Here on the screen you can see magnetic field lines. When a magnet is dipped in iron fillings, we can observe that the iron fillings cling to the end of the magnet as the attraction is maximum at the end of the magnet. End of the magnet, these two poles, north pole and south pole. Here iron fillings will be cling like that, and because why it's cling like that? Because here the magnetic attraction is maximum. Strength is maximum at the poles. It comes, magnetic field lines comes out from the north pole and goes inside to south poles, and it never intersect each other. Why they never intersect each other at two means they will form a two direction, which is impossible, and it makes a closed loop inside the magnet also. These ends are known as poles of the magnet. Magnetic poles always exist in pairs. Whenever a magnet is suspended freely in mid-air, means like that, if you will suspend a magnet, mid-air always point towards north-south direction. Pole pointing towards geographic north, geographic south is known as south pole, and the pole pointing towards geographic north is known as north pole. Let's understand this. If you are suspending any magnet, suppose it is north south, and this is your direction, east, west, north and south. So this pole, this magnet will it will be stable like that in towards north and south pole. This will be your magnet. So geographic north will be your north pole and geographic south will be your south pole. Like poles repel, unlike poles attract each other. It means two like poles will repel each other. It will not attract, it will repel each other, and two unlike poles they will attract each other. The magnetic force between the two magnets is greater when the distance between these magnets are lesser, because it depends on distance. Introduction. This was your introduction. Now let's see experiment of Oersted. Before that, magnetic effect of current. In definition, you can give an electric current flow of electric charge produces magnetic effect in the space around the conductor called strength of magnetic field or simply magnetic field. We will understand this. I will describe it. Let's come on Oersted experiment. You can see on the screen that this is Oersted experiment. According to Oersted, when current was allowed to flow through a wire placed parallel to the axis of a magnetic needle kept directly below the wire, the needle was found to deflect from its normal position. Means see this picture. In 1820, Hans Christian Ørsted, Dutch professor of physics, was delivering a lecture on electricity to show how an electric current heated a wire. Here, wire is given of XY length. This is your wire. So it's a complete circuit. Here it is connected with the battery plus positive with the positive and negative terminal. Current is flowing through this wire, and here's a key and resistance. So heated a wire, he connected the wire to the terminal of a big battery. Big battery means this is your big battery. Surprisingly, the needle of the compass which was placed near the wire, this is your compass, magnetic compass which we see, which was placed near the wire, swung around only to swung back again to its normal position pointing north when the wire was disconnected. Wire was disconnected with the battery when there is no flow of current. But when the current was flowing through the wire, it starts deflecting. This compass starts deflecting. So he observed that when the current is passing through this wire, there must be a magnetic field. That's why compass was and its needle was deflecting. Through the observation, Oersted showed that electricity and magnetism were related phenomena. So this was your observation of Oersted. He experimentally demonstrated that an electric current carrying wire behaves like a magnet and produces magnetic field in the space around it. So the conductor behaves like a magnet till the electric current is flowing through it. So this was your wire. When the current was flowing through this wire in this XY part, the compass was it has showed a deflection. This was what your Oersted experiment. Thank you. Now in next part we will see magnetic compass.